global forecast, climatologists believe that the recent severe weather patterns we've seen will continue to plague many areas around the world.
Since you can't control the weather or people, how can you assure the reliability of critical operations in the face of natural and man-made disasters? Look no further than the leader in exceeding industry standards with research-powered solutions, Evaptec. Evaptec is proud to introduce the FM-approved Series ES and ESP cooling towers. The Series ES and ESP cooling towers are the first fiberglass cooling tower products to receive a certificate of compliance according to FM Approval's published Standard 4930 and are designed to resist destruction by natural hazards and accidents caused by fire while still maintaining cooling capacity. The Series ES cooling tower is designed for multi-cell FM-approved applications whenever 4 or more cells are required. In an exploded view of this typical 4-cell Series ES cooling tower, we reveal its internal structure of fire-retardant fiberglass framing. Firewall partitions are standard on the ES and are constructed of fire-proofed reinforced concrete known as FireStop. FireStop prevents fire from spreading to adjacent cells and surrounding structures. The ES cooling tower is provided with standard PVC fill, and its water distribution system is constructed of fire-retardant headers and PVC laterals. PVC drift eliminators are positioned above the distribution piping. The tower is then encased on 4 sides with a layer of FireStop reinforced concrete panels that create a liner around the tower perimeter. The FireStop liner and partitions contain the fire to its cell of origin. The ES cooling tower's final layer of protection is provided by a hardened casing known as SafeWall. SafeWall resists damage due to airborne debris and extreme wind forces caused by tornadoes and hurricanes. Depending on the application, the ES can be provided without louvers or with wide space or cellular louvers. The tower is then capped with a fire-retardant fan deck and fan cylinders. The Series ES, designed to contain the fire. For a higher degree of protection from fire and natural hazards, Evaptec designed the Series ESP, which is the first PVC film-fill fiberglass single-cell cooling tower ever to be FM approved. The ESP can be provided as a single-cell or multi-cell design without the FM-approved thermal redundancy requirement. In this illustration, we show a 2-cell ESP. The internal structural framework of the ESP includes the same fire-retardant structural members, fan deck, fan cylinders, and header piping found in the Series ES. However, adjacent cells are separated by SafeWall partitions. The Series ESP is built with Evaptec's new revolutionary self-extinguishing Franklin fill and eliminators. They utilize a proprietary PVC with a flame spread of 0. When exposed to fire, the unique characteristics of the Franklin PVC materials create a charring effect that chokes airflow and inhibits the spread of fire. Because of the tremendous fire-resistant benefits of Franklin PVC, the Series ESP does not require FireStop partitions and liners. To provide further protection from natural hazards like hurricanes and tornadoes, the Series ESP also incorporates the hardened SafeWall casing system. Franklin Fill and the Series ESP eliminates the thermal redundancy requirement of Factory Mutual Approval Standard 4930. The Series ESP, taking FM approval to a higher level. The Series ES and ESP are a result of many years and large investments in research and development. Evaptec's VP of Engineering, John Ahern, was instrumental in the development of these products and offers an in-depth perspective on the testing performed to meet the rigorous requirements of the 2010 FM Standard 4930.
The testing involves burn testing, full-scale burn testing. It involves structural testing for casing and for fan cylinders for missile testing. And for the casing panels, it involves cyclic pressure testing to simulate hurricane and tornado wind forces. The burn test starts with the pan of heptane underneath the fill. Heptane burns extremely hot, and the volume is such that it burns for 20 to 30 minutes. The PVC fill propagates the flame throughout the whole cell, and the entire inside of the cooling tower is burned away. To keep the fire from propagating to the adjacent cells or outside the cooling tower on the sidewalls, fire stop is installed around the perimeter of the cooling tower cell. The ESP tower utilizes Franklin fill and eliminators. The same pan of heptane is placed underneath the fill. The fire propagates up through the fill and creates a chimney effect. It does not propagate within the cell, and it goes through the eliminators and serves to vent the tower. So all the heat is just vented up through the fill, up through the eliminators, and out the fan cylinder. The hole is about a 3 foot plus or minus diameter, and so there's no real damage on the cooling tower. The cooling tower can be operated with very little decrease in capacity. In addition to the burn test, we must also satisfy some structural tests. One of those structural tests is a cyclic wind loading for the casing panel section, and the number of cycles for our testing was over 30,000. The pressure is released and put on, released and put on for both the windward and the leeward direction. For 4930 to comply with hurricane region forces, wind forces, a missile test was required. We shot a 2x4 missile, and it still passed the test because the cooling tower was still operational. In addition to that, the fan cylinder testing required a 2x4 to be shot at the fan cylinder segment, and our fan cylinder showed no detectable deflection in the throat area where the fan blade is, meaning that the fan would still be able to operate even after hit by the 2x4 missile. The end goal is to make sure the cooling tower operates after the storm.
Let's revisit Franklin fill and see what makes it so special. This burn test video comparison shows two FM-approved towers. The tower on the left uses normal PVC fill material. As you can see, the fire is raging inside the cooling tower enclosure, but it is contained within the cell. The tower on the right uses Franklin fill. This tower is experiencing a dramatically smaller fire, even with the fire in both towers being ignited with the same fuel source. Now, let's take a look inside the towers. The FM-approved tower on the left has experienced total destruction of the internal components. In contrast, the tower on the right using Franklin fill and its zero flame spread rating has limited the fire damage to a small area above the fire source. That's what's so special about Franklin fill.
Contact EvapTech today for your next project requiring cooling tower operations capable of withstanding accidents and natural disasters.